Chapter 8, we return to the lecture for Chapter 8, 8.7. This section we start talking about, instead of a random arrival based on time interval, uh, this section we're going to discuss what if we have a so-called appointment scheduled arrival. So first, we're going to talk about how to set up an appointment arrival in the SIMIO. Um, and also, we're going to discuss the issues when we have a two different type of arrival. So in the DMV places nowadays, you can schedule your appointment online, and they will call you or give you an estimate when you should come in. And then you have a so-called walk-in customer as well. And this has happened uh, in many service type of facilities such as DMV and the clinic, so-called. You have a scheduled appointment. Also, you have a walk-in appointment. Was two different type of arrival, and then we discussed the possibility using a so-called priority scheme in the system and some of the complication or issues related to priority. So in this section, we assume we have a appointment switch, and we start with the appointment table. Okay, we're using a data table, and they insert a daytime column called schedule time. Then we actually insert the time and the appointment time for the arrival. And then we show you how to implement it on the model, adding additional resource source for scheduled arrival. On top of the original, we have the inter-arrival time. In fact, in this example, we're using a so-called rate table to specify the arrival pattern for each 30 hours. And all right, we start talking about this in the model right now, and let's see how we started with the model we have in 8 points, section 8, 8.6 to begin with. In the beginning, we're trying to set up a schedule arrival, adding a regular data table. Okay, we'll call them schedule table. Okay, for that, adding a property called daytime, and this is schedule time. Okay, schedule time, we can actually start with what day we want to schedule. In this example, what we have is start with 8:30 a.m. Then we have another one at 9 a.m. Have another one 9:30 a.m. Have another one 10 a.m. We have 4 scheduled arrival in the morning, and we have actually 4 in the afternoon. For 2 p.m. I have, and 2:30 p.m. 3 p.m. 3 p.m. and 3:30. p.m. Okay, we have total 8 arrival on this. And then next step, what we do is go back to create another source. Okay, this source is called scheduled arrivals. Then I'm just using the connector, connect the arrival to the thing. Checking the scheduled arrival, we're still using the same entity called entity applicant. Instead of using the inter arrival time, I'm going to referring to the arrival table. Choose the arrival table. I just have defined scheduled table arrival time. Okay, so this is pretty much it for this process. And also in this arrival, what we try to do, entity arrival pattern. Here we have other arrival information. First is we are to introduce arrival time per slot as 1. So each appointed arrival, meaning I have 1 arrival over here. The next thing we want to discuss is the so-called arrival time deviation. The arrival time deviation is based on the appointed arrival. Customer usually can arrive early, arrive approximately on time, and arrival late. So we give it a so-called approximate arrival deviation. So this one follows a random per distribution. Okay, per distribution with earliest customer can come in 10 minutes early, or 3 minutes early, or 5 minutes late, based on the per distribution. Also, we can specify a no-show possibility. In our case, is so-called probably 5% of the customer didn't show up. In the clinics or DMV situation, the customer may decide not to show up to this. So this is what we have for this part. Next, we're going to, based on this, and assign the scheduled arrival should have a higher priority than the walk-in customer. Okay, so here I'm going to change this to walk-in. This is easy to implement, so we go to state assignment on this. Okay, before exiting, we basically show a model give a priority. By default, the SIMIO for each entity has a so-called model entity state variable set up called priority by default. So I'm just going to use 2 for the scheduled arrival. Go back to the walk-in, doing the same thing. State assignment before exiting. I'm doing the same thing right here. Model entity, priority, equals to 1 for the walk-in. So I'm trying to create the scheduled arrival has a higher priority um, than the walk-in. So the scheduled arrival has a priority of 2. Walk-in has a priority of 1. In this case, later on, we're using the largest value first to rank all the queue. We'll show you how to do that in a minute. You can set up it the other way around, meaning the lower number in terms of priority has a higher priority. Then you're using the smallest value first type of situation. All right. Um, Then we're trying to collect statistic, and this is something we need to collect statistic for the scheduled arrival and the walk-in. Same thing for the walk-in, schedule. We also want to, using the data table we have set up previously, they have the same mixtures of 25% is permit applicant, 25% is trying to apply for new license, 50% is doing renewal. And the passing rate for the written test and the driving test are the same. So we need to use the process we have defined previously, and down here, okay, the schedule arrival created entity. So source arrival created entity. So here we're going to run the same for that. When the entity was created, we're going to run that process called created entity. Basically, we do the set row, determine which type of applicant it is, and we can subsequently do the same thing. So these two arrival are about the same, other than one is so-called random arrival based on the arrival rate table. One is scheduled arrival based on the scheduled arrival time, and both of the arrival string goes through the registration. Okay. Then the next step, what we do is trying to set up a tally statistic to collect the flow time or the so-called time in the system for both type of arrival. Go to the definition area, set up two tally statistic. One we call this tally statistic walk-in and flow time, which means is all right. And the other one is instead of walk-in is scheduled flow time. Both of them, be careful, always remember to do these. Their unit type set up to time, and also the category, we call it flow time, and data item set up for time in the system. Just for organize my output grid later on. Flow time in the system. Similar to previous before. So here we can even have this as walk-in applicant, and the data source will be scheduled. All right, so once we set it up, we show you several ways to collect tally statistic before. Today we're going to show you one more new method. Is in the input node of the sync unit. We can in the sync node, we can collect statistic as well. So here is what I have. Click on the input node for the sync station. You see a tally statistic portion, okay, and tally statistic portion, and we can do that uh, from here. Directly we can, for the exit portion, we're adding one more called uh, entity exit. By default is when entity exit, we're using collect a tally statistic. But today I'm going to using a condition, customer condition. What is the condition then? Um, if the model entity priority we have is equals to 1, that means this is a walk-in customer. So I'm going to collect the tally statistic for the walk-in, and the expression will be the model entity and time in the system, okay, as a collected value for this tally. Adding another one, instead of entity exit, I'm using a customer condition, and this condition is model entity's a priority is equal to 2, which means that this is a scheduled entity arrival. I'm going to using scheduled flow time. Expression is the same using time in model entity dot time in system. As collected. Okay. To collect the statistic on this, I'm going to set up a all right, so here we're trying to run this model, and you can see that. Pretty much the same with the before. We haven't added any priority yet, but this is running both the scheduled customer, scheduled applicants, and the walk-in customer, walk-in applicant have identical priority. And we can look at the result. Just showing you the the result we have here. Where we have a walk-in customer, this is a float time 239 minutes on the average. We have a so-called scheduled arrival. You see that? Okay, if we're running the simulation, we see that simulation stop, but the issue is I don't see any scheduled customer applicant showed up in the statistic. Find out what is the problem and go back to the facility and runs. You see that actually when we set up the schedule, I scheduled the arrivals actually October 2nd, 2018, but my simulation running starting from October 1st. So we need to run into the right day, and that's what there's to it. Okay, running for October 2nd scenario. All right, so October 2nd, and so we can have some scheduled arrival in that case. Go back to the result. Of course, the scheduled arrival showed up. Scheduled arrival actually has average flow time of the 39 minutes, and walk-in arrival has average flow time of 92 minutes. It's almost triple, actually double, more than double of this schedule. So the next things what we need to do is um, next thing we want to do is incorporate the so-called uh, priority scheme. So therefore, we're going to set it for the first for the registration, for the driving test, for the pictures station. We using a instead of here is a ranking rule. Instead of using the uh, first in first out, we're going to using largest value first, and by default is using the uh, system model entity priority. We're trying to do the same for these three tester station. So we go back in, the same thing, the ranking rules in the process logic, and choosing the largest value first and using model entity. So we're giving all these servers have a different follow the priority scheme using largest value first and based on the uh, model entity entity priority. So let's run this again, see what happened. Okay, doing good. And run. If I run this model, we get an error message, and this is saying the ranking expression is not valid. After digging for a while and I find out in the process we describe in the section 8.5, we have these so-called data entry actually running by a token as well. As also, each one of those has a so-called processing time count uh, value or taking a break type of thing. And these type of event actually triggered by the system, which is the model, triggered by the model instead of the entity. We need to take care of that kind of situation as well. So what we do is for these three these three server, instead of just using the largest value first, we have to using a dynamic selection rule as well. And the dynamic selection rule is, uh, uh, sorry, the ranking expression. Okay, the ranking expression by default is using the entity priority. So, but we need to take care of the model priority as well. So we call there are two different type of arrival priority. One is walk-in priority equals to 1. The other one is scheduled priority equals to 2. I'm going to give it the model, which is the breakdowns and well, clean up type of data entry type of thing, model entity priority to 3. So this is fairly simple to do using a math function called if the it is an entity. Okay, I'm going to use this corresponding entity priority. Or otherwise, I'm going to assign the priority equals to 3. So this function reads as a math function, is a math if function, checking if it is a entity, okay, coming in to trigger this to come into the server. If it is using corresponding entity priority, if it's not, or could otherwise using priority number 3. So here we can rerun this simulation and have no error showed up. And this is pretty much what we trying to do. Um, and the next what we're trying to do is the issues over here. I still have these 3 tester, and each one of the tester have their own input queue. So customer choosing priority didn't make too much sense to these 3. We would like to create a unified queue to make sure these 3 are competing on same streamline of entity as well. To do this, we need a dummy resources, and basically what we put it on. And this resource, what I have is, we call it dummy pass. So we call the tester key, just like a key. If I get this key, then I can go into the tester. Otherwise, I have to wait for getting this key. And the key has a capacity of 3, just same number as the tester I have. And I can specify the priority on this key. The priority on this key will be ranking expression. It's basically model entity priority. Okay. So this is supposed to be entity. Okay. So this will be similar, but we need to, at this registration process, um, after it's done processing, actually uh, in the output node section, and when we entering the output node, we need to seize the key before I can move on. So here we're using add-on process again. We exercise this quite often in this section, this chapter, when we enter the output node. So here, when we get into the output node, this add-on process, when enter, okay, when we enter this output node, we're going to seize the key. Simple. So seize key, basically. So once we have this key, we can have a unified priority scheme for all 3. I'm going to seize the resource key. Okay, test the key based on the preferred order. Okay, so and then somehow we need to release the key. When we're going to release the key? When we go into data entry, which means after the process. So after I go into the tester, when I finish my process, and when we after processing, and then I actually exit, we need to run the process data entry portion. So here we go to the process again. After I assign this to data entry, then I can release the key. Release the key right here. I'm going to make sure release key. Release the resource for the next one. All right, and this is going on the same thing. Release the tester key. Okay, go back to run the system. Zoom out a little bit. To see that the key actually can be run on, let me add a table for it. And the expression is capacity. Wait a second. Add a label. This is capacity dot remaining or utilized. Either way, utilized means how many are busy, remaining how many are remain unused. That's using remaining for this one. So now I have can run this. We see that the number of keys left is basically how many of the tester station available or in the data entry process. Okay. One more thing I need to address over here. Right now we're giving the scheduled appointment, appointment arrival higher priority. You see that the scheduled appointment give it higher priority, and the walk-in actually going pretty long. So what we're trying to see if we can, if the schedule nothing else, it's scheduled arrival has entity, scheduled arrival entity has a higher priority. But if the walk-in customers already spent more than 30 minutes in the system, then I also want them to have higher priority as well. So how do I do that? How do I do that? Okay. So go to the tester, and we have value expression. So if these three, okay, for example, this guy, instead of going largest value first, okay, go to the model entity. What I have is trying to set up if model entity equals to 2, dynamic selection rule. Let's like this. Okay, go into the dynamic selection rule and using the largest value first as well. Instead of using these, I'm going to select candidate priority either equals to 2 or candidate entity time in the system greater than half hours. To make sure we're using parentheses to separate these two conditions. Okay, so here I'm going to give it either candidate entity is equals to 2, which has the highest priority right now as a scheduled customer, or if the candidate entity time in the system is more than 30 minutes. So this case, we're giving walk-in customer slightly higher. So go into dynamic as well, choosing largest value first. Doing the same thing for his. Okay. For this guy. I'm going to rerun the system again, seeing the result. Okay, so scheduled system are going to be given as similar. I actually didn't have too much, meaning we have around the same thing result showing up. Okay, this is what we do concluding this section 8.7. We will continue to section 8.8 to talk about simulation length and replication using the experiment. Okay, we're going to conclude.